instruments for the study of nuclear energy.
When you think of nuclear power, what comes to mind first? I'm sure you're imagining a variety of images, not least of which are large, expensive, and potentially dangerous facilities with huge cones of billowing smoke. My name is Chris Cook. I'm from C5 Capital, and today I'm going to speak to you about next generation nuclear technology. Because the facts about nuclear energy are actually quite interesting and tell a more balanced story. Nuclear energy is a technology that we have relied upon for over half a century to produce low carbon energy. In fact, traditional nuclear plants are supplying a substantial amount of the world's electricity, completely carbon-free. Over 20% of annual electricity in the US and about 25% of the power in the UK is supplied by nuclear energy. It's a staggering 70% in France. But in countries like Germany and China, it's only 5 to 10% because of a strong incumbent reliance on coal, amongst other reasons. There's no question that adoption of nuclear energy can significantly accelerate our path to carbon neutrality. Yet it's not a technology that's been widely accepted, primarily due to concerns about historical safety risks and storage, as well as inherited biases and more often a dependency on coal and natural gas. Those are all big issues for Europe. But that may be about to change, and many early investors are just realizing it. Next generation nuclear technology is redefining carbon-free energy and solving for the key issues that have previously impeded broad-scale adoption. Those key issues involve substantial solutions to cost, material improvements in safety and ongoing maintenance, and safe storage. Next generation technology, as led by small modular reactors, SMRs, are nuclear fission reactors that are now being designed to take the scale of nuclear plants down significantly and enable innovative features like inherent safety, where harmful emissions are engineered to be impossible, according to the laws of physics. SMRs are designed for easy manufacture and transport, broadening their potential geographic reach, and they offer 5 times the fuel efficiency of traditional nuclear reactors. Traditional nuclear reactors only extract about 4% of the energy that you could feasibly get out of uranium fuel, leaving 96% as waste. That's an incredible number when you think about it. All that effort and risk, and still 96% waste. It's because traditional nuclear has required costly and complex processes, which are outmoded and still require expensive and almost infinite storage solutions. Next generation SMRs use a new kind of fuel called TRISO fuel that's much more efficient. The US Department of Energy has called TRISO fuel the most robust nuclear fuel on Earth. Picture a spear about this size. Inside, there are thousands of tiny TRISO particles that harness the power of fission better than conventional uranium dioxide fuel. The spherical shape of TRISO fuel is designed so it contains the uranium in an impenetrable ceramic fuel element. It can be stored long-term, right on site, taking up minimal space, and it yields 5 times the output of traditional fuel. This is a significant innovation that reduces the amount of radioactive waste produced while generating nuclear energy more efficiently, making transport, use, and long-term storage simple, and preventing security risks associated with moving the waste and fission products from fuel forms into storage containers as in the past. Think about that for a minute. Engineering advancements have enabled the production of a fuel that cannot melt. You still might be picturing smokestacks and large concrete facilities, but the new technology means no more expensive, gigantic concrete and steel structures to build and maintain, just to safely contain nuclear energy production. The TRISO pebble is already surrounded by 4 barrier layers that act in concert to stabilize and contain the uranium kernel under all conditions and in all temperatures. It works in a high-temperature gas reactor that does not require water for cooling, making meltdowns impossible. Now, as regards size, a typical 1,000 megawatt nuclear facility in the United States needs a little more than 1 square mile to operate. The size of a typical SMR facility is about the size of a 2-story building. SMRs are modular, so one 80 megawatt reactor, for example, can be scaled into a 4-pack, 320 megawatt power plant to provide more energy as needed. SMRs take about 1% of traditional nuclear reactor facility space. The technology is also available in micro-reactor size. Micro-reactors are 100 to 1,000 times smaller than traditional nuclear reactors, and they will be transportable by truck, plane, and shipping containers, able to reach remote and underserved locations. It's hard to believe that there was once a time when computers took up entire rooms. Think about it. It cost IBM roughly $200,000 to manufacture a precursor to the computer, which was a large-scale calculator in 1939. It was a 5-ton, 51-foot-long mechanical beast that ran its first calculation in 1943. Now we sit here using very lean 2 to 3 pound devices, which cost about $120 to produce. On an average day, one PC is produced by a major manufacturer every 1.5 seconds. That would be 40 PCs every minute. This is the level of transformation that happens after 50 years of engineering and research. Nuclear reactors have also seen 4 generations of innovation since their origins in the 1940s. The energy transition is seeing traditional nuclear get smaller, more affordable, safer, and more agile. Most traditional nuclear plants were built over 35 years ago, and all 420 of those in operation today must be replaced by 2050. SMRs are well positioned to replace the traditional reactors and fast-track our path to decarbonization. They're also positioned to replace coal-burning plants that must be taken out of production now. Okay, for a second here, let's look at demand of electricity. With global consumption on track to double by 2050, we need to invest in new forms of energy to meet this demand. Electric cars, IoT, electric everything. It's go, go, go. But the speed and scale of the energy transition to meet this demand has been slow. We're still looking at a massive energy gap after harnessing the full potential of all forms of identified energy sources, like oil, natural gas, all renewables, and existing nuclear. The gap is dramatic, and frankly, it's a critical infrastructure security risk. The good news is that we are seeing global leadership around next-generation energy. The US government is providing substantial funding and support for next-generation nuclear technology through R&D programs with the Department of Energy and Department of Defense, and allocating a record $1.8 billion to invest in nuclear in the fiscal 2022 budget. For early investors, this is creating an addressable market that is global in scale and which de-risks investments in the area of SMR as the choice technology that can deliver our clean energy future. Let's focus on the US for a minute. President Biden and his new administration are remaking how America looks. They're remaking how America works. There has never been a climate spending policy in the order of $1 trillion. Never. The ambition to radically reduce carbon emissions has never had such strong policy and budget behind it. And next generation nuclear is a big part of this $1 trillion spend. This is coming together at a pivotal time. I'm sure you've read summaries of the latest UN climate report. The report was startling in its findings. The report is clear that while it may be difficult to reverse many of the existing adverse consequences, many of the most dire effects of climate change can still be avoided if aggressive action is taken now. We can effect immediate, rapid, and large-scale reductions in greenhouse gas emissions by advancing next-generation nuclear energy. That's why next-generation nuclear needs to be the backbone of the clean energy mix. You know, as the saying goes, you never get a second chance to make a first impression. You've heard of old nuclear, not such a good first impression, right? So now we want to introduce for the first time the incredible innovations happening today in next-generation nuclear. Small modular reactors are the future of global non-carbon energy. If you want to learn more about what C5 Capital is doing to invest in and support the clean energy transition, please get in touch with our teams to learn more. Thanks very much.